In this video, we're going to go through the reactivity trends. So the first thing that you need to know is that valence electrons are what cause reactions, and they also are what are used in forming chemical bonds. Elements with the same number of valence electrons react in similar ways and have similar properties. So with just that fact, which of the following would have properties most similar to calcium? So let's see where these are on the periodic table. So we have calcium, which is right here in group 2. Potassium is in group 1. Argon is way over here in group 8. Magnesium is in group 2, the same as calcium. And then carbon is in group 4. So yeah, that's not going to work. So magnesium and calcium are in the same group. So magnesium would be the best fit here. Alright. It is easier to gain or lose the easier it is to gain or lose electrons, the more reactive an element will be. As you go down a group on the periodic table, here's what happens. So group the first row on the periodic table, the first period, you have 1 orbital. On the second period, you have 2 orbitals. And in the third period, you have 3. And it keeps going. So the atoms get bigger and bigger and bigger as you go down a group on the periodic table. Now, the most important thing that you need to realize is that the valence electrons, or the electrons in the outer shell, get further and further and further away as you go down that group. That means the valence electrons are weakly attracted to the nucleus, so the attraction gets weaker as you go further and further away. So, as those electrons get further away, the easier it is to take those electrons and remove them and transfer them from one atom to the other. That's where a reaction happens. So, when you have something that's really small, like hydrogen, everything's held in really tightly, and it's not going to be very reactive. Whereas if you have something that's further away on the periodic table, like if we looked down the group, like francium, that's really far. That's a big atom. So those valence electrons are going to be really far away. So here it says draw Bohr diagrams of lithium and sodium. Identify which is more reactive and explain why. So lithium is in group 1. And it has 2. Let's do this. So lithium is in group 1. It has 2. Lithium is number 3, so our atom will look just like that. And then sodium. Sodium is in the 3rd period, and it has 11. So it'll look like this. So this is very similar to what we just drew. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So this is lithium. This is sodium. That valence electron in sodium is a lot further away from the nucleus, so it's going to be held looser and will be more reactive. Okay, as you go across the period, from left to right, the number of protons increases. So potassium, calcium, scandium, so 19, 20, 21. So as we go to the right, we're increasing the number of protons. More protons, more pull. More protons. Should copyright that. More protons equals more pull. It's going to hold those valence electrons a lot tighter to the nucleus, and it is less likely to let them go. So if you have something that's in the same period, so like lithium, beryllium, they're in the same period. Beryllium has more protons, so it is going to be less reactive than lithium. Boron has 1 more than beryllium, so boron would be less reactive than beryllium. So as you move to the right, more protons, and again, more protons, more pull.